Hi, my name's Ernest from LiFePO4 Oz, and I'm going to go through the setup of the JK BMS. Now, if you haven't seen our previous video where I set up and I wire the BMS, then there'll be a link up here somewhere. But what I'm going to do now is jump into the BMS and the app to set it up. If you haven't got the app, then you can scan the QR code on the front of the BMS to download the app. And I'll also show you how to do it through the App Store. So let's jump in. To set up the JK BMS once you've got it wired, I've already downloaded the app, which is this JK BMS app here. However, if you haven't already got it, you can scan the QR code on the front of the BMS or just go into the App Store. Now I'm Apple, so you can go there, or Google Play, just search for it. So JK BMS, hit search, and you can see that it's that one there. I'll click open. If you hit scan and you go to connect to your BMS, okay, and it asks us for a password, the default password is 1234. Okay, you can rename the BMS. So if I name this, something like, LiFePO4 Oz, I can do that. But if you've got multiple BMSs, you can do that. Okay, scan, there we go, it'll come up with LiFePO4 Oz. So I can go in there. Now, to set up the settings, we click on settings. Now, these settings here are the default settings that will come with the BMS. Okay, so to first change it, we'll go verify password. Now the default password is 123456. I'll click verify. Now at the top you'll see lithium ion or Li-ion, LiFePO4, LTO. So these are the different battery types you can set up with this BMS. So lithium ion, LiFePO4. Now these are the default settings. If I click on LiFePO4, it'll load into the advanced settings, the default settings for LiFePO4. Now, obviously we're going to go and change that. Now, the other thing as well that I recommend that you do is you modify your password, okay? So the old password is 123456, and I might change it to, say, 112233. Something like that, so that way, if you go into a caravan or marina, someone can't jump in and change your settings. So that's how you change your settings. Okay, now let's go through the settings. So the very first one, cell count. We've got a 12 volt kit here. So the number of cells I've got is 4 cells. I'm not quite sure why it's not detecting that automatically, but we'll put that in. Battery capacity. Okay, the cells that I've used are 202 amp hours, so I'll put that in. If you've done a capacity test on your bank, and it's come in higher than that, which they will if they're out of the box, you can put that in as well. The next setting, balance trig volt. Now what this is what voltage difference between the cells do you want to have before the balancer kicks in. In other words, in this instance, if the biggest variance between the highest charged cell and the lowest charged cell is more than 0.01 of a volt, then the balancer will start. If it's less than that, the balancer will stay inactive. Okay, I'm happy to leave it at that, or if you wanted to change it to, say, 0.02, you can go and change that. Okay, calibrating voltage. Okay, now what this is if you measure the voltage of your pack, okay, with a multimeter, it's telling me 13.21, but if it was 13.3, then you would put 13.3 in there. But because mine's 13.21, I'll leave it at that. Same with the calibrating current. If you need to find, or if you're finding that you're drawing out current out of the BMS and it's not quite right, then you can update that setting to calibrate it. So let's get into the settings. So the advanced settings, start balance volt. Okay, what voltage do we want before the active balancer within the BMS starts to balance? Now, there's a lot of people out there, or there's some people out there that say they want to leave it until later in the charge profile to do it, say 3.4. I personally don't agree with that. The reason being is that between 3.4 and 3.65, the voltage in a cell can increase dramatically before the at that point in the charge profile. So I prefer to set mine at 3.2. The reason being is it gives the active balancer a chance to balance the cells before any of the cells start to run away. Okay, so and this also will factor in if you've got one cell in your pack that has lower lower internal resistance than another cell, again, it's going to be able to deal with that issue sooner rather than later. Maximum balance current. Now, this is to do with the active balancer. It has a 2 amp active balancing function in the BMS, so I'm going to leave it at 2. If you're dealing with lower amp hour cells, for example, like lithium ion, where they're only sort of 2 amp hour cells, then you might want to taper that off. But for the capacity cells that we deal in, I'm happy to leave that at 2. Okay. Now, cell OVP, which stands for over voltage protect. What that basically means is what's the highest that you want the voltage to be. Now, we used to set this to 3.6. Okay, the reason being is that it gave us a little bit of a buffer between the very highest voltage of these cells, which is 3.65, and where the BMS would turn off. Now, because of the settings in this BMS has been updated since last doing our video, I'm now happy to set this at 3.65, and I'll tell you why in a second. All right. Now, I'm going to jump a setting, and I'm going to go to cell OVPR, which stands for over voltage protection reset. And I'm going to change this to say 3. We'll still leave it at 3.55. Above there, all right, is SOC, which stands for state of charge, 100% volt. Now, what this basically is it means that you can set at what point do you want your battery bank to state that it's at 100% of the usable capacity, not total capacity, usable capacity. So again, before we used to set the over voltage protect to 3.6 and then the over voltage protect reset to 3.55. But now that we've got this new setting, what will happen is when you're charging the cell, the individual cells will be measured, and as soon as one cell gets to 3.6 volts, it's going to treat the pack as if it's 100% charged. Okay. Now, if it ever reaches 3.65, okay, it's basically gonna disconnect all the charging mechanisms, which it should be doing when it's at 100% SOC anyway. But what will happen is when you're charging up, it'll hit 3.6. The SOC 100% will not allow any current to go into the cells to charge it. However, it'll still allow charge to come out. So you'll still be able to discharge your pack. However, you won't be able to charge the pack until it hits the cell OVPR, the cell over voltage protect reset. So once one of the cells comes below all of the cells come below 3.55 volts, then the BMS will allow charge to start going back into the cells. Okay. All right. Moving on. Cell UVPR, which is under voltage protect reset. Okay. Now, very similarly to what is the over voltage protect. However, it's sort of like a bit of a bell curve. So this is at what point do you want it to restart? This is similar to the state of charge 100%, but it's the other direction. At what point do you want to assess that the battery is fully discharged? Okay. Now, we recommend that you don't discharge your cells more than 20%. So we set this to 3 volts. Now, it's going to chuck a hissy fit. I'll show you. It's going to say failed. The reason being is 3 volts is higher than the restart setting. Okay, so I'll fix that. Okay, so the cell under voltage protect. What's the lowest, the very lowest do you want to actually have your cells? Now, again, we used to set this to 3 volts. Now that that they've got that 0%, I would maybe set this to 2.8. And again, it's throwing an error because of, I'll show you this setting here, this one here. Okay, and that's why it's throwing an error, because the 3 volt is higher than the SOC 0% is higher than the under voltage protect reset. So let's change this, and I'm going to change this to 0.05 for example. Okay, so let me explain how this BMS is now going to work, right? On a discharge side of things, it will basically come down, and as soon as it hits the SOC 0% of 3 volts, it will actually not allow any more current to be discharged out of the battery bank until it hits 3.05. And at that point, it will hit the under voltage protect reset, and it will allow discharge to start happening again out of that battery bank. Okay, it'll still allow charge to go in, it just won't allow any charge to be coming out. Below the cell UVP, okay, which is under voltage protect, there's power off. Now, what this power off is at what point do you want the BMS to actually be disconnected totally? Now, in this battery, what will typically happen is it'll come out and it'll hit, in the settings we've got, it'll hit 3%, or 3 volts, and it'll be at 0% of usable capacity, but the total capacity, we're sort of saying that it's 2.8. You could put that to 2.5 if you want to, but we're saying it'll come. But once it starts allowing no charge to be coming out of the bank, the BMS will still be active. Now, the BMS requires power to run, okay? So the BMS will still draw current out of the battery in order to be active or be on. However, if we go the power off and we put that to 2.5, what will happen is it will stay alive until the power off hits 2.5 volts. Okay, once the A cell hits 2.5, the BMS will disconnect totally. Okay, Volt Smart Sleep. Now this is a new setting. This setting here, because they've updated the BMS and the app, what this is, I personally would, have this say at, 3.0, okay? And it's sitting at 3 volts. It will activate the setting here, the time smart sleep. So it's currently set for 24 hours, okay? And so to explain it, if the battery bank goes to 3 volts, it has 0 current going in or out, and it's in that state for at least 24 hours, okay, or for 24 hours, the BMS will then turn off. Okay, next one, continue charge current. What this basically is how much charge current do you want to allow to be going into the BMS or into the battery bank. These are rated for, say 200 amps, so I'm happy to put it in 200 amps, but for example, most cells, they like to be charged at 0.05 C. I'll give an example. Actually, I should probably set that to 100 because I've got 200 amp hour cells and 0.05 C is 100 amp. Okay, now look, you can charge them higher, but this is the optimum charging rate. Okay, so you can set that whatever you want. Okay, over current protect delay. Okay, now so the top setting there, which is 100, okay, it will sustain 100 amps for at least 30 seconds before the BMS will disconnect. Now, these BMSs that we have, they're a 200 amp BMS with a 350 amp peak. So it will sustain a 100 amp charging current for 30 seconds, and then once it's reached 30 seconds, then the BMS will disconnect, okay? Now, the setting below that, which is charge over current protect reset, it's how long will the BMS wait until it allows charge current to start coming back in. So let's say you've got that set to 100 amps. Once it hits, say, 101 amps, it'll sustain that for 30 seconds. And then once it's gone over 30 seconds, it will disconnect for at least, or for 60 seconds. And then after 60 seconds, it'll turn back on and allow current to start coming back, or charge current start to coming back. Same thing with this setting here, okay, so the discharge current, again, these are 200 amp hour cells. You can choose how you want to discharge them. They'll take 200 amps every day of the week. So I'm happy to leave that at 200, but you can change that if you want. You might, have a device that can't handle more than X number of amps, so you can change that if you want there. Okay, same thing. How long do you want it to sustain that maximum before the BMS detects. So it currently is set to 300 seconds, which is weird. So I'll change that to 30 seconds. So again, it'll sustain 200 amps for 30 seconds. After the 30-second period, the BMS will disconnect. It will then wait 60 seconds and then it'll turn back on, or not turn back on, but it'll allow discharge to continue. Okay, charge over temperature protect. That basically means that the BMS will basically allow the cell to get to 70 degrees, okay, and if it gets to 70 degrees, it will again allow charge to stop occurring into the bank. Okay, so the two temperature probes that are on the BMS, that's what measures the temperature. Okay, if any one of the cells get to 70 degrees, which I've never ever seen that before, it'll basically stop charge going in. What charge OTPR, which is over temperature protect reset, it will basically allow charge to start going back into the cell once a cell or all of the cells are below 60 degrees. So same as the discharge OTP, so discharge over temperature protect. If any one of the cells gets to 70 degrees during discharge, it will again disconnect the BMS. Once all the cells are below 60 degrees, it'll allow discharge to continue. Okay. Charge under temperature protect. Really be charging these cells below zero. Okay, so this setting here, under temperature protect. Okay, I'll change that to 0 degrees because, it's because of this setting here. Okay, so where do we want it to restart? Okay, so in this instance, what it'll do is it'll allow the temperature of the BMS or the cells to come down to 0 degrees. It won't allow any charge to happen after it's at 0 degrees or below. However, once it's back up to 2 degrees, okay, it will allow charge to start going back into the cells. Okay, MOS over temperature protect. So inside the BMS, they have something that's called an MOS. Okay, if the temperature goes above 100 degrees, which I think is pretty excessive, I personally would probably change that back down to say 70, and it's going to throw a hissy fit because this one is above it, so we'll change that to 60. Okay, so if the MOS temperature within the BMS reaches 70 degrees, again it'll stop. Once the temperature comes down below 60 degrees, it'll allow the BMS to continue working. Okay, SCP, short circuit protection delay. Okay, so the BMS is now able to measure short circuits, very similar to a circuit breaker. So how many microseconds do you want the BMS to allow or detect it? So basically, it will detect a short circuit for 1500 milliseconds, which is next to nothing. And then it'll wait 30 seconds before the BMS recommences. These bottom settings, which are further down here, okay, so device address, it's set to 1. All of this information here, all these ones down the bottom, is to do with your BMS talking with, communicating with other devices like an inverter. So for example, if you've got a BMS that's connected into a communication board and then into a inverter, that's what these settings here. So basically it's address 1, do you want to, that's what this BMS would be. Input data, so this is basically just is actually talking with the system. So, I'll put in myself, okay. Now, with these ones here, you'll see UART protocol number. You can actually set up what protocol do you want to use to communicate with the UART, yeah? And same with the CAM, what communication protocol do you want to work with? Okay, so you can select that. Again, we don't have a whole lot of people communicating with inverters and that sort of stuff using these BMSs, but you can do that if you want. This is not the video that you need to watch if you want to do that. Okay, con wire resistance settings. Okay, that's basically the resistance of your individual wires. The reason why you want to do that is to allow for differential or variances in the internal resistance of the wires. So when it's measuring the internal resistance of the individual cells for the active balancer. And that's pretty much all the settings, okay? So go through, if you want to set up those settings, by all means do so. I can see here there's a couple of settings that haven't been set up, so I'm going to change that to 3 volts. Okay, control. Okay, in the controls you can set up what you want. So for example, this charge, okay, this basically means, do you want charge to be able to go into the bank? Okay, same with discharge. Do you want the BMS to allow discharge to come out of the bank? Balance, self-explanatory in my opinion. Basically, do you want the BMS to be balancing your cells? We can turn that on and off, okay? Okay, so in the settings, we've got emergency. Now, what this is, highly recommend that you don't activate it, but basically what it is if any one of the safety parameters have been hit, so any one of these, it will basically ignore it and the BMS will still allow the current to flow through it. So it basically ignores all the safety parameters. So highly recommend that you don't use that. Same with disable temperature sensor. For whatever reason you want to disable the temperature sensor, maybe it's faulty and you just need to get some power happening or something like that, then you can do that. Display always on. That's basically if I believe if you've got the display, the JK BMS display, and I think it's got a sleep mode, so if you turn that on, it stays on all the time. Otherwise, it may go into a sleep mode until you activate it. Smart sleep on. Okay, now what this is if we go back to the settings and you look at the settings here, which is the smart sleep settings. This smart sleep just here, so we set it to 3 volts, and if it didn't get any current in or out for 24 hours, then it would go into sleep. So basically this smart sleep setting on and off, that's what that setting is, okay? So you know, it's up to you if you want to sort of use that setting. Okay, we've got the time setting here, okay? So I've just calibrated the time to today, which is 1st of March 2024. So that's how you calibrate it. So in terms of the BMS, that's all the settings that you really need to know about. You can see now that up the top, okay, the charge and discharge is on, the balance is off. The reason being is, even though the balance is on in the settings here, the balance is off there. The reason being is the active balancer, or if you look at the difference or the variance between the cells, they're not more than 0.01 difference of each other, hence the reason why the balancer is not active, okay? And you can see now that the resistance of all the wires have actually come up as well now. Okay, so that was a quick video on how to set up the JK BMS. If you need to know any more information about setting up the BMS or any of our other products, jump onto our website, LiFePO4Oz.com. And if you need to reach out, you can talk to us through either the chat or even go onto the Contact Us page. And remember, before setting up any LiFePO for cells or battery kits, please review our safety guidelines.